Load balancers. Let us explore the core network appliance known as the load balancer, the master traffic controller of the modern data center. In a high-demand network environment, a single server, no matter how powerful, has a physical limit on how many requests it can handle. If thousands of users try to access a website at the exact same second, a single host will become overwhelmed, slow down, and eventually crash. A load balancer is a specialized appliance that sits in front of a group or a farm of servers. Its primary job is to act as a single point of contact and distribute incoming traffic evenly across all the available hosts, ensuring that no single machine is overworked while others sit idle. The architecture of high availability. The load balancer uses a single, public identity known as a virtual IP, or VIP when you type a web address into your browser. The DNS directs you to this VIP address on the load balancer. The load balancer then looks at its internal list of real servers and decides which one is best suited to handle your specific request. This creates a high level of redundancy and high availability. If one of the servers in the farm has a hardware failure or needs to be taken offline for maintenance, the load balancer simply stops sending traffic to that specific machine and reroutes everything to the remaining healthy servers. To the end user, the website stays online and responsive, and they never even know a server has failed. The selection algorithms, how traffic is divided. To determine which server gets the next request, the load balancer uses a specific mathematical rule called a load balancing algorithm. As a network professional, you must know the three most common methods. First is round robin. This is the simplest method. The load balancer sends the first request to server 1, the second to server 2, the third to server 3, and then starts over at the top. It is a fair and simple rotation that works well if all your servers have the same hardware power. Second is weighted round robin. This is used when you have a mix of old and new hardware. You can tell the load balancer that server 1 is twice as powerful as the others. The load balancer will then send 2 requests to server 1 for every 1 request it sends to the smaller servers. Third is least connections. This is a more intelligent approach. The load balancer constantly monitors how many active sessions each server is currently handling. It will always send the next new user to the server with the lowest current workload. This is the most efficient method for complex tasks, like processing online orders or streaming video. Health checks and persistence. A load balancer is only effective if it knows which servers are actually working. To do this, the appliance performs constant health checks. Every few seconds, it pings the servers or sends a small HTTP request. If a server does not respond within a set time, the load balancer marks it as down and immediately stops sending it any traffic until it passes a health check again. Another critical concept is session persistence, or sticky sessions. In many applications, like a shopping cart, your data is stored in the temporary memory of the specific server you are talking to. If the load balancer moved your next click to a different server in the middle of your session, your shopping cart would suddenly appear empty. To prevent this, the load balancer can be configured to stick a specific user to the same server for the entire duration of their visit. Security and SSL offloading. From a cybersecurity perspective, the load balancer provides a vital layer of protection. It acts as a shield, hiding the true IP addresses of your internal servers from the public internet. An attacker can only see the load balancer's VIP address, making it much harder to target a specific server for a hack. Furthermore, many load balancers perform SSL offloading. This is where the heavy mathematical task of encrypting and decrypting HTTPS traffic is handled by the load balancer itself, rather than the web servers. By taking this burden away from the servers can use 100% of their processing power to deliver web content, making the entire network significantly faster. By mastering the distribution of traffic through intelligent algorithms and ensuring high availability through constant health checks. You will be prepared to manage large-scale web and application environments that never go offline.